7 Rust project ideas for senior developers. Projects that are actually worth putting on your resume. Starting with number 1, a terminal tool your whole team will steal. For this project, you're essentially building a terminal UI app. The best version of this project is one that optimizes either your workflow or your team's workflow at your company. It's really common for an individual developer or a team to have some repetitive or annoying process that a terminal app can streamline. It could be a dashboard for your internal deployment pipeline, or a wrapper for multi-step commands that your team runs regularly. Rust is great for tools like this because it allows you to ship a single binary that anyone can use, without installing any additional software. On top of that, Rust has a great ecosystem for building terminal tools. Crates like Ratatouille for UI rendering, Clap for argument parsing, or Syntect for syntax highlighting. And one of the biggest benefits of a project like this is it's one of the easiest things to ship at your workplace. You typically don't need to ask your manager for approval, especially if it's a tool you're building for yourself. And if you use this tool in your workplace, even if it's just for yourself, then it's real Rust experience that you can put on your resume that is tied to your current workplace. The other great thing about this project is it's usually very fast to ship. Getting a working CLI tool can be a weekend project. And best of all, if the tool is good, then there's a chance that your team will adopt it, which means you can influence Rust adoption at your company. A lot of engineers that I've worked with in our Rust Live Accelerator program use this approach to get real experience on their resume, which helped them land their first Rust role. The second project is building your own programming language. Basically, you're building a program that reads code in a small language and actually runs it. First, it will read raw source text and parse it into tokens. This is what's called the lexer. And then you would organize those tokens in a tree to represent your program's structure. This is the job of the parser, which produces an AST, which is shorthand for abstract syntax tree. And then you would execute that tree, either by running the nodes directly, which is known as a tree walking interpreter and is the easiest place to start, or by translating the tree into compact instructions and running them on a mini virtual machine that you create, which is known as a bytecode VM and takes more effort to build. One great thing about Rust is that its enums and exhaustive pattern matching make it pretty well suited to parse ASTs. In general, the biggest benefit of doing this project is the skill sets that you'll gain. Taking raw text, turning it into a structure, and then doing something useful with that structure is a core skill that will allow you to build many other things. For example, domain-specific languages, linters, formatters, and static analysis tools, query builders and ORMs, templating engines, serializers, and protocol parsers. For systems programmers, building your own programming language is almost a rite of passage. So pick this project if you want a way to gain systems programming experience and have something useful to show for it at the same time. And develop a core skill set that you can then leverage to build other things in the systems programming space. The third project is building your own async runtime. Almost every Rust developer has used the Tokio crate, but very few Rust developers know how the Tokio runtime, or any async runtime for that matter, actually works. Well, the best way to learn is to build your own from scratch. Through this process, you'll learn about complicated topics that you were probably always curious about. Things like futures and state machines, wakers, the pin smart pointer, and more. Not only is this project fun, but it will look great on your resume and will help you prepare for Rust interviews. Because in my experience, Rust interviews tend to focus a lot on async Rust, and more specifically your understanding of async Rust, the different tools available to you, and their trade-offs. Now you might be wondering, if I were to build my own async runtime, where would I even start? Well, I got some good news. Jack O'Connor actually wrote a blog post about how to build your own async runtime. It's called Async Rust in 3 parts, and I'll include a link to it in the description of this video. The fourth project is building a mini serverless platform. Think about it as your own mini version of AWS Lambda or Cloudflare workers. The problem you're essentially trying to solve is how do you take somebody's untrusted code and safely run it? WebAssembly is the modern answer to this. It's a portable, compiled format that runs in a sandbox. The guest code can only do what you explicitly allow. By default, there's no access to the file system, network, or outside memory access unless you explicitly allow it. So this project would involve building a host program that takes a WASM file somebody else wrote, gives it a small controlled API to call into, passes data back and forth, and enforces limits. And Rust is perfect for this because it has first-class WebAssembly support. Building this project has several benefits. The first benefit is proving that you have an understanding of modern backend infrastructure. It also proves that you can reason about security and isolation. Things like running untrusted code safely, sandboxing, and capability-based security. Not to mention, a project like this looks great on your resume and in demos, especially if you're targeting backend roles. The fifth project is building your own storage engine. The heart of any database is its storage engine, the part that actually puts bytes on disk and retrieves them. This project would involve building an embedded storage engine, which is essentially a library that you compile into your app, instead of a separate server that you connect to over the network. You can start by building a key value store. The API will be simple to build, and the real work would be making it fast and durable. Writing should be quick, reading should be quick, and data should not be lost if the program crashes. Rust is great for this because it allows you to ship blazingly fast code, which is also memory safe and robust, things that a storage engine requires. One benefit of building a project like this is you'll finally understand how databases work under the hood. It will also teach you important concepts like durability, crash consistency, and performance trade-offs. Exactly the type of things senior engineers should be familiar with. The sixth project is building a Linux observability tool with eBPF. Normally, the Linux kernel is off limits to your code, but eBPF changes that. eBPF is a revolutionary Linux kernel technology that lets you run your own mini programs inside the Linux kernel. You can attach your program to a hook. For example, run this every time any process makes a syscall, sends a network packet, or enters or exits a function. This allows you to get an extreme level of visibility into the operating system with almost no overhead. And that's why eBPF is used in modern infrastructure. Specifically 3 areas: observability, for example, tracing, profiling, and metrics; security, spotting suspicious behavior the moment it happens; and networking, things like load balancing, firewalls, and routing between containers. The great thing about Rust is we have the IO library, which allows you to write eBPF-based applications. By building this project, you get to learn one of the hottest technologies in modern-day infrastructure. It's also a great differentiator on your resume, because very few engineers have written eBPF programs. In general, if you're interested in backend, security, or systems programming, I highly recommend this project. The seventh project is rebuilding a tool you use every day. To give you an example, in my development workflow, I use Whisperflow so I can speak my thoughts and then have that translated into text, which I can feed to an LLM. And I use Speechify to read back the text that the LLM outputs. And there were a few problems I've faced with these tools. First of all, these are multiple tools with multiple subscriptions that I have to pay for. Second of all, I don't have much control over how my data is being processed. And third of all, these tools were just not that performant. They would eat up my RAM and sometimes crash on me. So I decided to build Murmur, my own voice-to-text and text-to-speech tool. I built it with Rust and Tauri with the exact features that I wanted. And now I use it every day and absolutely love it. The benefit of building a tool that you use personally is, first of all, it's a lot of fun. And second of all, it's a real use case. You are your own user or customer. So it's definitely something you can put on your portfolio. And if you want help deciding what senior level project you should build and also get mentorship while you're building that project, then check out our Rust Live Accelerator. It's our tailored Rust mentorship program where we help developers go beyond YouTube videos, build production-grade Rust systems, and land their first Rust job. You can join the waitlist for the next cohort by heading over to letsgetrusty.com/join or by clicking the link in the pinned comment below. When you join the waitlist, we'll also send you our Rust developer roadmap as a small gift. So tap the link, join the waitlist, and I'll talk to you very soon.